Hi Year 4, it's Mrs. Eggleshaw here. I'm going to take you through your maths lesson today, which is going to be all about efficient ways to multiply numbers. So you're going to need your maths book and a pencil, and then I'll just sit ready and I'll share my screen and hopefully we can get started. So what I'm going to do is I'm going to go through some of the things that I want you to do, and then I'll tell you when is a good time to pause the video and then have a go at what I've asked you to do on the screen, and then you can just press play again when you're ready and we'll go through some of the answers. So I hope that makes sense. Let's have a go and see how this goes. So for our warm-up today, we're going to be using the greater than, less than symbols to show which number is greater or less out of the two. So out of each set of numbers. So we've got two sets of numbers here. If you look at the first one together, and then you can do some on your own. So with working out which number is bigger or greater, the first thing we need to do is a bit like when we're ordering words alphabetically. We look at the number on the far left in the same way that we look at the first letter of a word. So it's helpful, all of these numbers are in the thousands, so that's really useful. So if we look at the thousands in this number, we can see that it's the same as the thousands in this number. It's a really good idea to read the numbers out loud to yourself. So 3,330, 3,303. And sometimes we can kind of tell where those symbols go just by reading those numbers. This one's a little bit tricky because it's got the thousands column. There's a 3 in both of those. So those are the same. So just like when we're ordering words, we then go on to the next column, which is the hundreds column. And there's a 3 in that column too, and a 3 there as well. So that doesn't help us. They're both equal still at the moment, aren't they? So move along into the tens column here. In this one, we've got a 3. And in this number, we've got a 0. So there we go. So we can see that 3, 3 tens is worth 30, and that's obviously bigger than no tens at all. So this number is the biggest number. Now, when you're doing your greater than, less than symbols, if you remember from Key Stage 1, the little crocodile that kind of eats the bigger number, if you like. So we put our greater than, less than symbol facing the larger number like that, as if the crocodile mouth's eating the number. So if you just pause the video here, and then you can have a little go at doing the others, and then we'll come back together. Just press play again when you're ready, and then we'll go through some of the answers before our main lesson. Okay. Okay, so hopefully you paused that and you've written those numbers out and done your greater than, less than symbols in them, and we can just have a quick go through them to check that you're understanding and you know what you're doing. So here again, we're going to start. We've got two numbers, they're both thousands in the thousands, so that's helpful. So we're going to look at the thousands first, the far left number first. That's the thousands column, the biggest column. We've got 4 in that one, and we've got 4 in that one, so they're both in the 4,000, so that doesn't help us. Looking again, moving across into the next biggest one, which is the hundreds. So we've got 9 in that column and we've got 9 in that column. So they've both got 900 in them, those numbers. So that's not going to help us either. So then we're going to move into the tens column. We've got 9 in this one. We've got 0 in this one. So like the one above, we can see 9 tens is obviously worth 90 and 0 tens is worth 0. So obviously this one is going to be the biggest number. So we have the symbol around that way again. Next one's a little bit more straightforward because we've got 5,000s here and we've got 4,000s here, and we all know that 5 is bigger than 4, so that number is going to be the bigger number. And it actually doesn't matter what numbers are after it. You can see here the numbers after are actually bigger, aren't they? There's 909 there, and there's 331 there, but that's all irrelevant. It doesn't matter because the biggest number, the biggest column, the biggest one here, the thousands, is bigger, so that makes that whole number bigger. Same down here, if we look at the thousands, we've got 6,000 here, 5,000 here. So this is obviously the bigger number. So we do our crocodile mouth, greater than, less than symbol facing that way. Then to this one, same as done before, 7,000 here, 7,000 there. No hundreds, 0 hundreds there. There's 1 10 there, and there's 9 tens there. So 9 tens is worth 90, and 1 10 is just worth 10. So obviously, that's going to make this one here the biggest number because it's got 90 It's got 9 tens, which is worth 90 rather than just 10. And then the bottom one, same again, starting with thousands, 8,000, 8,000, 0 hundreds, 0 hundreds. And we've got no tens there, and we've got 6 tens there, which is going to make this number here the bigger number, like that. Okay, so hopefully you got those right, and if you didn't, hopefully you can see where you went wrong when we went through the answers together. Okay, let's move on to the main part of our lesson then, multiplying using efficient methods. So I've got a sum here. Year 4 are calculating 25 times 8 mentally. What would the most efficient method for this be? Well, an efficient method just means the most straightforward, the easiest, the most practical method of doing something, which when you're doing this in maths, it actually can be different for different people. So what is your most efficient method, your easiest way of doing something, maybe different to the person next to you or another member of your class, for example, because they may just do maths in a different way to you. So I'm going to show you some different ways here, and maybe you may have your own ideas about which one you think is a useful way to do it. So the first way that we could do it is something like this. So we could do 20 times 8 is 160, and then 5 times 8 is 40. That's called partitioning. So basically we've chopped the 25, there's a 20 and there's a 5, look, up into more manageable chunks, and then we have just added the answers together. You could even do 10 times 8, 10 times 8, and then 5 times 8 if you wanted to, because 10 and 5 would make 25. So you might be looking at that thinking, 22 times 8 is a bit hard. How am I going to do that? But if you remember, we can use our knowledge of the 8 times table. If we know that 2 times 8 is 16, which hopefully you do, then you can use that knowledge to also know that 20 times 8 is 160. So we just multiply that up, and then it helps to do that. Or if we did 10 times 8, 10 times 8, we could do 10 times 8 is 80, another 10 times 8 is 80, like that, and add them together would make 160. 5 times 8 is 40. If you don't know your 8 times table very well, don't forget you can do it the other way around. So you could count in 5s until you get to 5 times 8. 5, 10, 15, 20, 25, 30, 35, 40. And then we're just doing a column addition to add those together. So that's one way of working out that sum, using that's like the partitioning method, if you like, which is what I've talked about down here. Look, partition the numbers into tens and ones, and then use your multiplication facts to help you. We were using 2 times 8 to help us know that 20 times 8 is 160. Okay, so another way is this way. You might know, because it's 25 times 8, you might know already that 25 times 4 is 100. So you might know that, you might know just it's a number fact that you're aware of. And then, so if you know that 25 times 4 is 100, you could then double it, because obviously you've got times 4, we're going to double it to make it times 8. And then obviously, then that would be 200. So you could do it that way. Obviously, if you know, if you don't know that 4 lots of 25 make 100, then that's not a very efficient way to do it, because you'd have to work that out, and that would be tricky. If you do know that, that can be a really quick and easy way to do it. Another way is this way. So you could do 25 times 10 first. And so you're doing times 10 instead of times 8. You're saying 25 times 8 is a bit tricky, but I do know how to do 25 times 10. So I'm going to do 25 times 10, which is 250. But what I've done is I've added too many lots of 25 on. I've done 10 lots of 25 and I only wanted to do 8. So then I have to take off the extra 2 that I added on. So I did two lots of 25 is 50. So I have to take that away and I'll end up with 200. Again, you might find if you're super good at multiplying by 10 and you're pretty good at taking away in column addition, you might find that a really useful way to do it. You may also be looking at that thinking, what has she just done there? In which case I would suggest that's not a great method for you to do, but have a look and see if you can see what I've done, because it can be a really useful way to do it. Okay, so we're timesing by 10 instead of 8, because it's easier, but then I have to take those extra 2 off because I did an extra 2. And then another way you could do it is you could say, right, okay, well, I know that I'm going to do 50 times 8, so I've doubled my 25. I'm going to do 50 times 8 because I can use my times table knowledge to work this out easily. So I can do 5 times 8 is 40, multiply it up to make it 400, and then just halve it. So I've done that way around as well. So that's kind of doubling this number to make the sum easier. But because I've doubled that number, I then have to halve it down here to work out the answer. Now, I would suggest, if you're thinking, well, that's lots of numbers all at once, have a go with a different number, which we'll try in a minute. But if you're not sure, I would start with this one here, the partitioning one, because it's just quite a straightforward, methodical way to do it when you're starting off. And these other ways kind of you need more sort of number facts and more to know what you're doing, really. So start off with this if you're not sure. We can move on to some of the others. So I'm going to do one of these together, and then you're going to have a little try at some yourself. So if we have a look at this one, we're talking about calculating 28 times 5 here. So what I've done is I've just put it into like a grid, like when we used to do grid method, just to chop it up a bit for you, to make it easier to understand. So I've got 20 here, it's a partitioning way that we did on the other page, and I've got 8 here, that's how I'm partitioning up. So I'm going to do 20 times 5 and write the answer in there, and I'm going to do 8 times 5, write the answer in there, and then I'm going to do a column addition to add them together. So 20 times 5, you might be thinking, oh lordy, I don't even know what 20 times 5 is. That's fine. Remember what we said, we use our knowledge, don't we? So if we just pretend that 0 isn't there for a minute, and we do 5 times 2, that's obviously suddenly a lot easier, isn't it? 5 times 2 is 10, or 2 times 5, 2 lots of 5. But then we mustn't forget that we were ignoring that 0. We need to multiply that up again. Oops. There we go. So we need to include that 0 in our answer. We can't just ignore it completely. We do have to put it back onto our answer. Then we've got 5 times 8. So we can do 5 times 8, and I can do my 5 times table for this. So I might count 5, 10, 15, 20, 25, 30, 35, 40, or I may just know that it's 40 already. And then I'm going to put my answer in the box. And then I've simply got to add those together. Now I can add those together in my head, and I know that 100 add 40 is 140. So I can just put that down as my answer. If I didn't know, then I could simply put that 40 under there, could write it out as a column addition like that and just add them up. But I'm not going to spend time doing that because that wouldn't be very efficient of me, because I already know what the answer is. So what I'd like you to do now is to just move that off, pause the video, and in a minute, and you're going to have a go at doing that. You're having a go at some yourself. So you put your multiplication symbol in there, 16 divided up, that's the tens. There's 1 10 and 6 ones, and then you're timesing it by 3. And then you work out the answers, add them together, do a column addition if you need to, and have a little go at the others too. So if you just pause the video, and then we'll go through a couple of the examples when we come back together in a minute. Okay, hopefully you've paused and had a little try at these. So I've already split for this one, the 16 into the 10s and the 1s, and then I've got my 3 there because I'm multiplying it by 3. I know that 3 times 10 is 30, so I can just stick that straight in, and then I can work out my 3 times 6. So I can either count in 3s, or I can count in 6s, depending on which multiplication table I know best. I know that 3 times 6 is 18, so I'm going to pop that in there. If you don't know your times tables, then sometimes if you can't count them easily on your fingers, sometimes it's a better idea to just write your times tables out so that you don't make any mistakes. It's good practice to write them out anyway. So then we've got 30 add 18, and I can add that together in my head. So in terms of being efficient, I know that that's 48. If I didn't know that that was 48, then what I would do is I would just put 30, and then I'd put my 18 underneath, and then I would make myself a little column addition, which is a bit tricky on this screen, but I'll try. Whoops. There we go. And then we can just write the answer underneath. So we can do 0, we start at top, don't we? 0, add 8 is 8, and then 3 add 1 is 4. So I'm just going to put that. It's a bit funny on here, I have to write it in a funny way, but Just move it down into the right place. So that would go under there like that, just about. And then the next one, we'll just do one more of these together. So perhaps do this one at the bottom, because it's got a different number in the tens column. So I'm going to divide that up, put my multiplication symbol in the corner there to remind me, and then I've got 20, so I've got 2 tens, and then I've got 3 there, and I'm timesing by 7, so I'm put that down there. And once again up here, I'm going to use my knowledge. So I'm going to, if that wasn't there, we can't put that now. I can do 2 times 7, I know is 14. There we go. And then I can just multiply that by 10 to include my 0 up here, which I ignored at the start. Then what 7 times 3? Again, I know that's 21, but if I wasn't sure, then I can write out my times tables or whatever I need to do to get that answer correct. Or I could even count in 3s, couldn't I, if I don't know my 7 times table. Then making sure I line it up properly. I either just add them mentally, which I think I can do. So I'm going to say, right, okay, my answer is 161. But if I wasn't sure, then what I could do would be to make myself a little column addition, making sure I line up. Obviously, I'm not going to put it here, am I, my number, because that will put that 2 in the hundreds column, and that's not where I want it to be. That's a 10 for 21, so I'd have to line up there. And then I do 0, add 1 is 1, 4, add 2 is 6, and then 1 add 0 is 6, and that will make 161 again. So it doesn't really matter if you write a column addition out or not, depending on whether you need to. Okay, so I hope those make sense, and obviously you would have done the same for that one too. So if we just move on, because I don't want to take too long. This is another way. Sometimes we're faced with ones with sums where that's not the most efficient way to do it. So if we've got 6 times 99, thinking about what we could do to work that out, we could still do it. We could partition that into 90 and 9, and we could do 6 times 9, 6 times 90, and then 6 times 9 and add them together, and that's fine too. But when it's 99, this is going back to when we did rounding, it's quite close to a much easier number to multiply, isn't it? There's a little clue down here in our steps to success. So we've got 99 is really close to 100. So I'm going to round that 99 up to 100. Okay. Now I have to remember that I'm going to have to take that extra one off at some point if I'm adding an extra set of 6 on. I'm going to do, instead of doing 99 lots of 6, I'm going to do 100 lots of 6. So 6 times 100. And I know that that is 100 because I'm really good at multiplying, and so are you. Good at multiplying by 100. We've done that lots of times. So I can do that quite easily in my head. So I'm going to do that. So now I've added 1 times 6, which is 6, too many, didn't I? Because I only was supposed to have 99 lots of times 6s, lots of 6, and I actually added 100 lots of 6. So I need to take one lot of 6 or one group of 6 back off again. So we need to take that 6 away from our answer. So I just need to, my 100, oops, actually 600, 600, oops, take away 6, and that is 594. So I know in your head you might want to do, I don't know how you might do that, you might count it back. So you might go 600, 599, 500, like that. What I did was, I know that if I take 6 away from the next group of 10, there'll be 4 left. So I knew that there would be 4 in there, and it sent it back to 594. But you can use a number square or a number line or whatever you'd like to help you to count those back. So what I'd like you to do now is to just pause it again, whilst I get rid of that. And I would like you to have a go at doing 3 times 99 and 8 times 99. So if we look at the 3 times 99 together to start you off, you're going to try instead and do 3 times 100, which you'll know what that answer is because you're super good at that. And then when you've done that, you've got to take one group of 3 off that time, haven't you? So whatever your answer is, you'll have to take 3 away from it, because it's one group of 3 is 3, so you have to take it away. And then down here, you'll do 8 times 100 and take one group of 8 away. So just pause the video now and have a go at that, and we'll come back together in a moment. Okay, So hopefully you've had a little try at those and they didn't cause you too much trouble. They are a bit tricky, especially knowing how much to take off at the end. So let's have a little look together. So we had 3 times 99 and we thought, that's a bit hard. 99 is one of those numbers. It's not very easy to multiply. So I'm going to multiply by 100 instead because they're nice and neat. And I know that 3 times 100 is 300. So that's great, except that's not my answer because I added one group of 3 too many. So it's not just one number, it's one group of 3, which is 3, isn't it? So I need to take away 3 from my 300 now. So I'm going to do 300 take away 3 next. Just going to get rid of that one because it's a bit confusing. There we go. So 300 take away 3. And I can do that in kind of any way I want, really. I can count back, so I can say 300, 299, 298, like that. Or I can just use my number bonds to 10, and I can say, well, I know that 3 and 7 make 10. So it's going to be 290 something, and it's going to be 297, because I know that 3 and 7 make 10 together. So my answer there is going to be 297. And then the last one, just going to move this up. The last one I asked you to look at was 8 times 99. So there I'm just going to do 8 times 100 to start with. And I know that that's 800. Nice easy one there. And then I have to take away one group of 8. So I'm not just taking away 1, I added one group extra, and in one group in the 8 times table there are 8. So 8 take away 8 again, can count back, or I can think, right, I know this is going to be 790 something. What goes with 8 to make 10? 8 and 2 make 10, so it's going to be 792. Okay, so again, it's about efficient methods. Use whichever way you find easiest to work out, count back or whatever. But that, I think you'll probably agree, doing that, even if it's a bit of a pickle to count back 800 take away 8, that's still much easier than trying to do 8 times 90 and then 8 times 9 and then add them together. That's going to be a much longer and much harder way to do it. So this is a more efficient way of doing it. So that's what this is talking about down here on the steps to success. Round the number, so in this case it's 99, round it up to 100 and subtract the difference. It worked the same if it was 101 as well. You could do 100 and then you just have to add on an extra group because you've added one not enough. Okay, let's move on to the next bit. So this is still into gold activities. Now you can see at the top here, saying whether it's silver or gold. So there's 2 methods here that have been used to calculate 49 times 6. So this method, the first one, method A, multiply 10 times 6 4 times, so that'd be the 40 times 6, and then add 9 times 6. So that's like our partitioning way that we were doing. So we would do 40 times 6, or 10 or 4 lots of 10 times 6, and then 9 times 6. So that's the first way. So if I just model that for you, so you could do 10 times 6, 10 times 6, 10, 4 times, or you could just do 40 times 6. And I can use my knowledge of the 6 times table. I know that 4 times 6 is 24. And then I'm going to multiply that by 10 to make it up to 240. And then I can do my 9 times 6. Which is 54. Again, need to write that out if I'm not sure what it is. Write my times tables out to help me. So 9 times 6 is 54, and then I can add them together in a column addition. So 0 and 4 is 4, 4 and 5 is 9, and then 2 add 0 is obviously 2. It's tricky not being able to write on here. So it would be there. So we can do it like that if we want to. So that's the sort of the silver method, the first method that we were learning, which is the one I'd advise you all to use, unless you are feeling particularly confident and you want to have a try at the other one too, in which case, by all means, have a go. This way is the rounding way. So this is the second part of the steps to success. So this is multiplying it by 49 is nearly 50, and then taking one group off. So we do 6 times, let's put it here, 50 times 6 equals, and I can use my knowledge of the times tables again, so we can count 5 times 6, and if we don't know our 6 times tables, we could do 5, 10, 15, 20, 25, 30, and count it up like that if we wanted to. And then we're going to multiply that by 10 again to make it into the, to take account of the fact that this is tens, because 5 times 6 is only using that as a 1. So we've got 50 times 6 is 300, sorry. And then we have to, because we added on 50 lots of 50 groups of 6, and we're only actually supposed to have 49, we've now got to take away one of those groups. So we've got to do 300, and we've got to take away one group of 6 there. So again, using my knowledge of the of my number bonds, I know it's going to be 290 something, and I know that 6 and 4 go together to make 100. So I know that's going to be 294, and obviously you can see we've got the same answer there. So this is a little bit of a trick question, and there's another one on the next page. It kind of says which is the most efficient way. I guess it depends on which way you prefer, and you know how your maths brain works, because they are both effective ways. It's just which is most efficient depends on who you are, how you do maths. So I would just like you to pause the video again in a second. And when you pause it, you're going to have a go at doing these both ways, okay? So this one is 71 times 7. So the first way that it's asking you to do, method A, multiply 10 by 7 times. So you can either do 7 times 10, 7 times 10. I don't think you really need to do that. I think you could probably just do 70 times 7 there at the start. And then you'd have to do 1 times 7. And then you'd add the answers together. Or then up here, multiply 70 by 7 and add 7. Sorry, that's this way, isn't it? Move that one across. So do that one there. And then this one is the multiplying it out by 10 7 times. So you could do 10 times 7 equals 70, like that. And you can do that 10 times. And already the fact that I don't want to type that out lots of times, 7 times, suggests which one might be the most efficient. Obviously, if you don't know how to work out 70 times 7, then that's perhaps not the most efficient for you. So use one of these methods, or both if you have time, and try and work out the answer. And we'll come back together in a second and just see what we get. Okay, hopefully you've had a little go at that. I'm not going to type this one out because I haven't got enough space. And it also, I was also thinking it's going to be really tricky to add all of those 7s up together, isn't it? So I'm just going to have a go at doing it this way first, and I'm going to do 7 times 7. So I'm going to ignore that 0 for the time being and just pretend that this is a single digit number, and I'll multiply it up by 10, the answer by 10 in a minute to kind of allow for that 0. So 7 times 7, I know is 49. Now, if I don't know that that's 49, then maybe I write it out the way on the left and add them all up. I don't know. And then I'm going to times that by 10 to make it into 490. And then I've got 1 times 7, which I know is 7. And then I can add those two together. So I will end up with 497 at the bottom. Okay. So for me, I think that the method B was the most efficient method, because it would just take me ages to write all those out. But that's only because I knew what 7 times 7 was. And if I didn't know what 7 times 7 was, then perhaps it would have been more sensible for me to write it this way. Okay, so let's move on to this one. This one, James calculated 33 times 8. Which method is the most efficient? So I just want you to have a pause of the video when I say pause. And I want you to look at each one and just see if you can work out what's happening in each one, and then just decide which one for you do you think would be the most efficient one. And I would definitely suggest that if you're not sure how one of them got the answer, then that's not the most efficient one for you. So which one is the most straightforward one for you? Just pause it and have a look. Okay, hopefully you've had a look at that. Again, as I said, you may not agree with me because it depends what you see when you look at numbers and things. I quite like this method on the left the most because I think 30 times 8, I know my 8 times tables. If I ignore that 0 a minute and do 3 times 8 is 24, and then times that by 10 to allow for that 0 again. And then 3 times 8, I already know is 24. That's literally one sum I have to do there. I have to know what 3 times 8 is, one multiplication, and then I can just add those answers together. And I found that quite a straightforward way. If you're not sure about what 3 times 8 is, I mean, you're going to have to work it out down here anyway, but you might want to chop it up a bit more, partition it a bit more, and do 20 times 8, and then 10 times 8, and then add those together. So that's okay as well. It's just an extra little step. Not quite as efficient as that one, but it's okay. This one here, I kind of think this one, in this case, this one isn't close to 40, isn't close to 33 really, is it? So I don't think this one's very efficient because it's doing 40 times 8, and then you have to take off 7 times 8, and that's quite a difficult sum, and it's quite a long sum, and it's quite, I just think that 40 isn't that close to 33. If anything, you could have done 30 times 8 and then added an extra 3 maybe. But then maybe you saw that one and you really like that one, and you would prefer, you know, if you're very good at taking away in columns and you get a bit muddled with adding, maybe you prefer that one. But I would say overall that first one is the one on the far left, 30 times 8 and then 3 times 8 is the most efficient method for that sum. Okay, this is the platinum tasks now. So I'm just going to show you these and talk you through them. And then if you want to have a go at these, I'm not going to go through the answers to these because your brain is probably really tired now. But you can have a little look through them. And maybe if you're not sure, if your parents are around or if you've got any time, you can talk to them. Then maybe you can look at it with them if you want to. But let's have a look at them together. Just talk you through if you want to have a try. 2 methods have been used to calculate 18 times 4. So it gives you method A and method B. And you have to just choose which method is most efficient and explain your reasoning. And what I would suggest that you do is that you do it both ways and see which one you find the most efficient. So on the one back here, I found, the one right back here in fact, I found out down here, I just realised straight away that I didn't want to write out 10 times 7 times. So I realised really quickly that that wasn't going to be the most efficient way for me. So start to do them and you'll probably figure out pretty quickly that there's one way that's more efficient than the other. So this way, multiply 20 times 4 and subtract 2. So that's this one at the bottom of my steps to success, which is basically rounding the number and then subtracting the difference. And then this one, multiply 10 times 4 and then 8 times 4 and add them together. So that is the one, that's the partitioning part. And then 2 methods been used here to do 17 times 3. And again, they've done 5 times 3 twice, or you could just do 10 times 3, couldn't you? And then 7 times 3 and add the amounts together. Or here, this one is, so that's the partitioning one. And then here is the sort of rounding one where they've rounded it up to 20 and then taken off 3 lots because they only needed 17. So they had 3 too many. So have a try at those and see how you get on. And I'm just going to move, once I've finished talking to you, I'm going to move it to the next page as well because there's an extra one on the last page too. So you have a go at those and decide which one you think is the most efficient method. That's those. So this one is 2 methods been used, 68 times 9. It tells you 2 different ways and you can pick which one is the most efficient. If you're finding these really tricky, what you can do is to challenge yourself to write down some 2-digit numbers and times them by a single-digit number and see if you can do it, at least maybe 3 or 4. See if you can do them using the partitioning method that we used at the start with a little grid. Okay, so hope that makes sense. If anything is really tricky or you need any help, then you can message us on Dojo and we'll try and help you out on that. But happy hunting. We'll be doing some more of this tomorrow. So don't worry if you feel like you need a bit more help, because we'll have another go at some more of this tomorrow. Okay, bye everybody.